All right, we'll continue on. Can pass an object by, let's see, different bindings. So we have to talk about binding here. So compile time binding, the necessary code for a call is generated by the compiler, known as static or early binding. Virtual binding occurs at program execution, not compiling time, and this is dealt with the virtual function. Why is this important? Because this is how Java actually did things with virtual, so to speak, except for it was just interfaces and abstract classes. So that's Java.
What is that?
Who uses that language? All right, runtime binding. Compiler does not generate the code for a function, but it generates the information to enable runtime system to generate specific code. Right. This is known as dynamic or late binding. To a formal parameter of the derived class. Sure. Unless it's virtualized. Wow, why are we throwing all these things out? Slicing problem, solution. Okay, why don't we just get an example? I'm going to destroy these slides in a moment.
Delete slides.
All right, we're just going to go do an example because this has gotten ridiculous. All right, whoa. This is the wrong class. There we go.
Oh, did you notice on one of your things on Blackboard, instead of saying lab 4, it says lab 1?
No, but remind me after class so I can fix it, push it, and then everyone will be happy again.
It says lab 1 instead of
I don't know if that will change the hack.
Blackboard.
Well, at least you won't be quite as miffed.
There we go.
All right, so let's create a good old shape.hpp. If not defined, shape.hpp underscore hpp, and let's convention. We'll go define it, and then we'll do the end if. So we'll have class shape, and I cannot remember how this was done. It's like virtual void draw equals 0. We'll create a virtual function called draw, set equal to 0, meaning it has no implementation.
Should we test it?
Sure, let's test it. I love that idea.
Why?
Why wouldn't we test it? So we'll include shape.hpp, int main, int argc, char, star arg, v. Yeah, I'll get to that. And 1, 2, 3, 4, return 0. Wow, this gvim did not do what I wanted to. Let's try that again. There we go. Gonna work this time? Yeah. Whoa, that's not what I wanted. Hit the wrong button. Okay, so let's see if it compiles. And then run it. Hey, it ran it. That's great. So, do you think we could create a shape class?
Sure. Why not?
Yeah, let's see what happens. Oh!
It broke.
Error, cannot declare variable sh to be of abstract type shape. Can we make it a shape pointer? Woohoo! Alright, so we made it a pointer and work.
Really the only issue I have.
Okay, well, hold on. Can we actually create this thing? Any guesses?
I'm going to say no.
We have one no?
I'm going to say maybe.
Maybe. It depends.
No?
No? We got a bunch of no's. Yeah, you can't do it. Because the following virtual functions are pure within shape.
Pure.
Pure. It's a pure virtual function because I set it equal to 0. So we need to have a shape. So we'll go and make it, I don't know, what shape do y'all want?
Circle.
Circle.
Circles are boring.
What?
Circles are boring.
EFI. Instead you'd like?
Here.
Hexagon.
Yeah, something complicated.
Pyramid. I don't even know how to spell that. Is that right? No, I know how to spell it.
I mean, you didn't know how to spell Moldeck last week either. So.
Alright, so if not defined, pyramid. Whew. Come on, boys.
This is gonna get fun.
define it in the if include shape.hpp. So we'll have, I don't know, class pyramid. How do we inherit?
Shape.
Which one?
Shape.
You want to inherit shape.
Right. What's the syntax?
Extends?
Yeah. No.
Nope.
No. Star. Black.
Nope, not splat.
Even just this
Colon,
Colons?
public, shape,
Dang.
Yeah.
Something.
Colon.
colon.
Got it.
Thanks, Jonah.
You're so welcome. Back to you, Dr. West.
Back to me. All right. So let's see. Can we create a pyramid?
We're building our own pyramid.
Pyramid was not declared in the scope. All right, I guess we'll have to include it.
Yeah, you have to include it first.
All right, hold on. Let's make. Let's see. Error cannot declare variable py to be of abstract type pyramid because the following virtual functions are pure within pyramid.
You gotta splat.
Spell it right. What do you mean?
Oh.
No. It's, oh, make a star.
Yeah.
It's me getting asterisk.
You mean splat it? All right. But can we actually create a pyramid?
Probably not.
No. It's going to be the same error. Same error. So what do we need to do inside a pyramid? Think of shape as implements. If we were implementing shape in Java, what does pyramid have to do?
It has to inherit.
It inherits shapes functions.
It
has to-
draw.
That has to actually do all of the shapes functions.
It has to implement
Those things.
that word, the thing with the stuff. All right. That was confusing. Include pyramid.hpp. Okay, that's. So what was this function? Void draw. All right, let's paste that. We don't need to call it virtual anymore. Pyramid : draw, and we'll just have it do. See out. I am a pyramid.
Oh, you're going to do the IO.
All right, sure. We'll include IOs. All right. So now we've implemented that function. Hopefully. Let's see. Can we do it now? Nope. Why not? I typed what wrong? I did?
Pyramid.
Pyramid.
I know. I'm so picky. Hold on. Oh, maybe I do need the word virtual right there. Do I really need that? I hope not. I do. All right. So now I forgot how to do this. That's great. Invalid new expression abstract type pyramid. Abstract. Because following are pure within pyramid. Probably because we never declared them not to be. All right, come on, C++. Error virtual outside of class declaration. Oh, I put it over here. That's just silly. Why would I do that? There we go. So a lot of fun with syntax. So you actually have to declare void draw, and then you have to implement draw, and then inside of it you can actually draw it. It's private. What did I do wrong?
Go back to the pyramid HPP
Mm-hmm.
and the shape HPP.
Mm-hmm.
Virtual.
Now virtual's right. We didn't make it public. And then we also need to make it public here.
You can make by default. Publish in a class.
Not in C++.
Of course not.
Everything's private by default.
That's annoying.
Only slightly. I'm a pyramid. Okay. All right.
How dare.
Well, that was lots of fun. Now let's see. What?
Nothing? Fun?
So can we do that? Can we set the shape variable equal to the pyramid variable?
No.
No.
I don't think so.
Nope, we can't. Because pyramid inherits from shape, so pyramid is the child of shape, therefore a pyramid is a shape.
But can a shape be a pyramid? No.
We could code it to be that way,
No, don't.
but yeah, semantically that makes no sense.
That's
All right.
a question for you.
How about, can we do this?
Yes.
Wait. Depends what the draw function is.
Let's find out. Yes, you can. Wasn't trying to be tricky. All right. Any questions about virtual functions?
Nope. Move on.
Good, because I really don't care about virtual functions.
I mean, we don't
You learned about implements in Java. The rest is syntax.
So like, what's the difference, like, exactly between
Virtual function and
yeah, the regular function, but what's the difference?
so a virtual function, you're saying I am not declaring the function here. This is really a virtual. You're creating a pointer to the function essentially. That'll be filled in later. And you're saying shape does not implement draw, but for it to be a shape, you have to have a draw function. So when you jump over to pyramid, that's why here in pyramid, I have a draw function. Notice it implements from shape, therefore pyramid needs to implement draw, or say draw is abstract, which just passes down, keeps the can down the road. But by pyramid's implementing draw, it's now a class that can be instantiated that implements the shape interface. Notice that in shape, I don't have code for draw. But in pyramid, I do. So it's saying, shape is saying, anything can be a shape as long as it implements this void draw function. Pyramid inherits from shape and then implements the void draw function. So inside of main, I can call draw on pyramid because it actually exists. I can set sh, which is a pointer to pyramid, pointer to shape, sorry. Sh is a pointer to shape, set equal to the pointer to a pyramid, and then call draw on the shape. And that's okay because what sh is pointing to is actually a pyramid, not just a shape.
In this class, are you going to be focused more on procedural or OOP, or object?
The OOP that we're going to focus on will be called parametric polymorphism, which if you recall generics inside of OOP, that's what I use in C++. There are two different schools of thought doing the inheritance method or the generic method or templating method. I am definitely on the templating side of the fence. Both have their pluses and minuses. Okay. Any other questions on this example? Because that's basically the lab.
Thank you.
All right, let me see if there's anything in here I missed. Array-based lists. Ordered list. Summary. All right, we're good. We're done.
Okay.
That was the lecture.
Yeah.